Hello good day viewers. In this tutorial we are going to talk about almost everything you need to know about a unit cycle. So what is a unit cycle? A unit cycle is a cycle of radius 1 unit, and this unit could be kilometer, centimeter, meter and what have you. So whenever you have a cycle of radius 1 unit, for example 1 centimeter, then that cycle is said to be a unit cycle. So it is as simple as that. So a cycle of radius 1 unit. And this is just the definition of a unit cycle. So what do you need to know about a unit cycle? Remember, we are still under trigonometry. Therefore, we are going to learn a lot. First of all, I would like to draw a cycle on y and x plane. So we have our cycle here on x and y plane. Remember, this is y-axis and this is x-axis. And since it is a unit cycle, from the origin to this point will be 1 unit as well. So all of these four legs will be 1 unit each. All right, I would like to draw a radius in the first quadrant because we have 4 quadrants: 1, 2, 3, and 4. These are 4 quadrants we have. And before we start, you should know that on x and y plane, this leg here is always positive. This is always positive as well. But this x-axis from the origin to the left hand side is negative, and anything below x-axis will be negative. Therefore, this leg is negative, this is also negative, this is positive, and this is positive. So you should take note of that. So let's assume we have a radius like this. Remember, it is going to be what? 1 unit as well. So what will be the coordinate here? Because we have infinitely many points on the line. So I'm talking about this particular point. What will be the coordinate at that point? It will be a value of x with a corresponding value of y, definitely. So how can we obtain this x and y in terms of trigonometric ratios? To do that, I'm going to form a right angle triangle here. This is a right angle, and we have our angle of reference, theta. So the distance from this to this will give us x, and the distance here will give us y. So how can we express x and y in terms of sine and cosine? Remember that cosine of an angle is equal to adjacent divided by the hypotenuse. And this is the adjacent side, which is x, divided by the hypotenuse, which is 1, because this is a unit cycle and the hypotenuse is 1. This implies that cosine of angle theta equal to x. What does it mean? It means that cosine of every angle depends on the value of x at that point. We have that sine of theta equal to opposite divided by the hypotenuse. Opposite is y and the hypotenuse is 1. So we have y divided by 1, which implies that sine of theta is equal to y. And hence we can replace x and y with cosine of theta and sine of theta respectively. Therefore, this particular point will be cosine of theta and sine of theta. So whenever you are looking for cosine of theta, look at the value of x at that point. If you are looking for sine of theta, you should look for the value of y at that point. All right, so now let us derive something very important here. Since we have seen that this is a right angle triangle, according to the Pythagoras theorem, it stated that x squared plus y squared equal to 1 squared. But we have seen that x and y can be replaced with cosine of theta and sine of theta respectively. So we have cosine of theta, but because x is the cosine of theta, right? It has a power of 2, therefore we have to square this as well. Cosine of theta, that is cosine squared theta. And y, which is sine of theta, will be y squared, which is sine squared theta, equal to 1 squared, which is 1. Can you remember this identity? We are familiar with this identity in one of our previous lessons. So this is another one. Before we move on to angles, I would like to show you something here very important. What if theta is equal to 45 degrees? We know that 45 degrees is halfway between 0 and 90 degrees, because this angle here is 90 degrees, and 45 will be halfway between 0 and 90 degrees, right? Therefore, the value of x and y will be the same because it is halfway. Let me show you. If you draw a line here horizontally, it will give us the corresponding value of y at that point. So whatever the value of y is at this point will be what? Sine of 45 degrees. And if you come down here, whatever value we have here will be cosine of 45 degrees. But we have seen that x squared plus y squared is equal to 1, right? According to unit cycle. So let's see if we can find sine and cosine of 45 degrees. Though we have obtained all of this in our previous lessons, I just want to show you that it is possible. So we have seen that x squared plus y squared is equal to 1 according to unit cycle. But at 45 degrees, both x and y are the same, so we can replace x and y with something. So x equal to y, let us equate them to be something like z, since they are all the same. So we have z squared plus another z squared. This is equal to 1, right? So we have 2z squares, 2z squared equal to 1. Divide both sides by 2. We have z squared equal to 1 divided by 2. Take square root of both sides. We have z alone equal to square root of 1 over 2. We only need the positive version because we are in the first quadrant. And remember that this leg and this leg are all positive, so we need the positive value here. So if you simplify this, square root of 1 is 1, square root of 2 will remain square root of 2. So how can we rationalize the denominator? By multiplying the bottom by root 2 and the top by root 2 as well for equivalency. So this will be 1 times root 2 is root 2, divided by root 2 times root 2 is root 4, and root 4 is 2, square root of 4. Therefore, z equal to this. But remember that z equal to x equal to y, which implies that x equal to root 2 over 2, y equal to root 2 over 2. But what can you remember about x and y? X is what? Cos theta. Cos theta equal to root 2 over 2. Y is sine theta equal to root 2 over 2. But remember that we have replaced theta with 45 degrees. Finally, it shows that cosine of 45 degrees equal to root 2 divided by 2. Likewise, sine of 45 degrees equals root 2 divided by 2. So these are some of the things you can see in a unit cycle. Next, I would like to show you that we have 16 special angles on a unit cycle on a Cartesian planes. So that is what we are going to do next. I have 2 unit cycles here. They are identical. Why? Because I would like to express this in degrees and the other one in radians. So let's start with degrees. Let's assume these are all in degrees. All right. Remember that if you go around a cycle, you have a complete of what? 360 degrees. This is what? It could be 0 degrees or 360 degrees. Why? If you assume that this is 0, though yeah, it is 0. If you go here, you have 90, 180, 270, 360. So this point can either be 0 degree or 360 degrees. So look at something very important. If you observe, we have how many segments? I have divided this cycle into 4 segments. 1, 2, 3, 4. So therefore, if we divide 360 by 4, we are going to obtain 90 degrees each. So we have 90 degrees here, 90 degrees, making 90 is 180. Therefore, this is 180 degrees, right? Another 90 times 3, this will give us 270 degrees. Another 90 will give us a complete cycle, which is 360 degrees. But remember, we have learned that the total radian round a cycle is 2 pi, right? So this could either be 0 or 2 pi. So what if we divide 2 pi by 4, because we have 4 segments here. So we take 2 pi, we divide by 4. To the simplest form, this will be pi divided by 2. So we have 1 pi divided by 2 here, just like the way we have 190 degrees here. And we have 2 of this. You know, of is multiplication. 2 of pi divided by 2. 2 will cancel 2. We have pi here. Can you see that? We have 3 pi divided by 2. We have 4 pi divided by 2 if you go round. And 4 pi divided by 2. 2 here, 1, 2 here, 2. We end up having 2 pi. You see that? Therefore, if you divide a cycle into 4 segments, you're going to have pi over 2 each. So therefore, you can see that angle of 90 degrees is equivalent to pi divided by 2 in radians. Angle of 180 degrees is equivalent to pi. Angle of 270 is equivalent to 3 pi divided by 2. And 360 is equivalent to 2 pi. This is that. Now I would like to divide these segments into 8. Alright. If we divided this into 8, let's start from the origin 0 or 360 degrees. So if you take your calculator and divide, you don't even need it, 360 degrees divided by 4, you're going to get 45 each. So we have 145 degrees here, another 45. This will give us, okay, just consider it as multiples. This will be 90, that is 45 times 1, 45 times 2, then we have what, 135 degrees. If you multiply by 4, you have 180 degrees. If you multiply by 5, you have 225 degrees. If you multiply by 6, you have 270, right? 270 degrees. If you multiply by 7, you have 315 degrees. If you multiply by 8, you have 360 degrees round a cycle. So what about the radians? If you start here, you have either 0 radian or 2 pi radian. So what if you decided to divide 2 pi by 8? 2 pi by 8. You have pi over 4 each. So you have 1 pi over 4 here. This will be 2 pi over 4, which you know to the simplest form will give us pi over 2. Therefore, 2 pi over 4 is the same thing as pi divided by 2. This will give us 3 pi over 4, right? 3 pi over 4. This will be 4 pi over 4. That is 4 pi over 4. The 4's will cancel, leaving only pi here, which is 180 degrees. This will give us 5 pi over 4. This will give us 6 pi over 4. But remember, we can reduce this to the lowest term. 2 can go into 6 exactly 3 times, so this is 3 pi. 2 can divide 4 exactly 2 times, so this is 3 pi over 2 instead of 6 pi over 4. Then this will be 7 pi over 4, and this will be 8 pi over 4. Just do it. 8 pi over 4. 4 divided by 8. 8 divided by 4 is 2, so this eventually equals 2 pi. So you can see that we have divided a cycle into 8 segments, and you can see the corresponding radians with their degrees. So 90 is equivalent to pi over 2. 135 degrees is equivalent to 3 pi over 4. 180 is pi. 225 is 5 pi over 4. 270 is 3 pi over 2. 315 degrees is equivalent to 7 pi over 4 in radians, and 360 degrees is equivalent to 2 pi. If it is 0 degree, you consider it as 0 radian. All right. Now let us move to the next portion. This time around, I have divided it into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's start with degrees. If you divide 360 degrees by 12, you have 30 degrees each. I want to show you that we have 16 spatial angles on a unit cycle on a Cartesian plane. So this will be 30 degrees because we divided 360 by 12, we have 30 each. Another 30 will give us 60. Another 30, we have 90. Another 30, we have 120. Another 30, we have 150. Another 30, we have 180. Another 30, we have 210 degrees. Another 30, we have 240 degrees. Another 30, we have 270 degrees. Another 30, we have 300 degrees. This is 330 degrees. And finally, we have 360 degrees. All right. So now let us look at these angles in radian again. So if you take 2 pi, which is complete cycle, you divide it into 12, each will be pi divided by 6. So if this is 0, the next one will be what? Pi divided by 6. This will be 2 pi divided by 6. But 2 can go into 6 exactly 3 times. So this is pi divided by 3. And this pi divided by 3 is equivalent to 60 degrees. Next, we have 3 pi divided by 6 here, right? But 3 can divide 6 exactly 2 times. So we have pi divided by 2 here instead. The next will be 4 pi divided by 6. This is 5 pi divided by 6. This is 6 pi divided by 6. Let me finish before we simplify them. This is 7 pi divided by 6. This is 8 pi divided by 6. This is 9 pi divided by 6. This is 10 pi divided by 6. This is 11 pi divided by 6. This is 12 pi divided by 6. All those I have written in red can be simplified. All right, let's go back. You see that we have a common factor of 2 between 4 and 6. 2 divides 4 exactly 2 times, so this is 2 pi. 2 divides 6 exactly 3 times, so this is 2 pi divided by 3 instead of 4 pi divided by 6. Coming here, you can see 6 divided by 6 is 1, so we have pi here, which is 180. Coming down here, 2 can divide 8 4 times. Then 2 can divide 6 3 times. So this angle here, which is 240 degrees, is equivalent to 4 pi divided by 3. 3 can divide 9 3 times, and 3 can divide 6 2 times. So we have 3 pi over 2 here. 3 pi divided by 2. 2 can divide 10 5 times, and 2 can divide 6 3 times. So we have 5 pi divided by 3. And lastly, you can see that 12 divided by 6 is 2. So we have 2 pi here. 2 pi. All right. So you can see that we have how many angles here? We have 12 of them with their corresponding degrees. So this is 30 degrees, which is pi divided by 6. We have 60, which is equivalent to pi divided by 3. 90, pi divided by 2. 120, 2 pi divided by 3. 150 degrees is 5 pi divided by 6. 180 is pi. 210 is 7 pi divided by 6. 240 is 4 pi divided by 3. 270 is 3 pi divided by 2. 300 is 5 pi divided by 3. 330 degrees is equivalent to 11 pi divided by 6. And lastly, 360 degrees is equal to 2 pi. So you can see that these are 12. we need 4 to make them what? 16. And that 4 are this. You can see them. Pi divided by 4, 3 pi divided by 4, 5 pi divided by 4, and 7 pi divided by 2, which is 45 degrees, because you can see it is only 45 degrees that is missing here. So if you come here, you can add all of them at once. So let me see, how can I write all of them together, including their degrees? Because if you count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 spatial angles. So this is 30 degrees, right? So we can either write it as 30 degrees or pi divided by 6, right? So the next one will be 45 degrees, or let me use the same color. This is blue, so I should have 30 degrees here, or pi divided by 6. So let me use black here. We have this to be 45 degrees, or pi divided by 4. Moving on, we have this angle to be 60 degrees. This is either 60 degrees or a radian as pi divided by 30. Then this is 90 degrees or pi divided by 2. And remember that this is either, if you call it 0 degree, you can also call it 0 radian. And if you call it 360 degrees, you can call it 2 pi, right? So one interesting thing about a unit cycle, you can obtain all other degrees or radian using the reference angles in the first quadrant. Just observe, you know that this is either 180 degrees or pi, right? This is 270 degrees or 3 pi divided by 2. Remember that. So if you observe, all these angles have their reference angles in the first quadrant. So if you want to find this one, though we have it here, you can see that here it is 120, right? So assuming you don't know it is 120, just observe, this and this have the same point on y-axis, right? So if this is 60 degrees, this must be 60 degrees less than 180 degrees. So the moment you subtract 60 degrees from 180, you shall obtain this one, assuming you don't know. So this will be 120 degrees. And you can see this is pi divided by 3, right, in radian. So this will be pi divided by 3 less than pi. So the moment you take pi, you subtract pi divided by 3, you know this is going to give us what? 2 pi divided by 3. 2 pi divided by 3. So O 2 pi divided by 3. If you want to confirm, let's do that. You see that? 2 pi divided by 3, which is equal to this. So you can do the same thing for all of these angles, but I'm not going to waste time doing that. This is going to be 45 degrees less than 180. So this is 135 degrees, or a radian as 3 pi divided by 4. Then the last one before 180 is either 150 degrees, which is 30 degrees less than 180. The moment you subtract 30 degrees from 180, you shall obtain 150. So this is 150 degrees, or a radian as 5 pi. We have obtained all of this. 5 pi divided by 6. Then coming down here, we have 180. If you move to the next, you have 210 degrees, or a radian as what? 7 pi divided by 6. Move to the next, we have 225 degrees, 225 degrees, or a radian as 5 pi divided by 4. Then the next one will be 240 degrees, or a radian as 4 pi divided by 3. Then this one, which is 270. Then we'll move to the next. After 270, we have 300. This is 300 degrees, or in radian as 5 pi divided by 3. Then the next one will be 315. This is 315 degrees, or in radian as 7 pi divided by 4. Then second to the last is 330 degrees. This is 330 degrees, or a radian as what? 11 pi divided by 6. So we have written all the spatial angles on a unit cycle. What is next? We would like to find their trigonometric ratios. So I'm only going to take sine and cosine, because once you know sine and cosine, you'll be able to obtain tangent, because tangent is a ratio of sine by cosine. If you are looking for tangent of 30 degrees, it is equivalent to sine of 30 degrees divided by cosine of 30 degrees. And they have their reciprocals, which is 1 divided by the ratio. Let me start with 30 degrees. The coordinate at that point, what will be the coordinate at that point? The coordinate at that point will be a value of x and a value of y. So value of x will determine what? Cosine of 30 degrees or cosine of pi divided by 6. We have obtained all of these three ratios in our previous lesson, right? Once you know these three, please do not cram all of this. I'm going to show you that they are all the same. They only differ by sign. It is either positive or negative. So in the first quadrant, all ratios are positive. In the second quadrant, those that depends on x will be negative, because this leg here, remember, it is negative, right? We know that this is 30 degrees. Even if you have forgotten, I can simply go back to show you. But these are the most important 4 coordinates. Remember that this line is 1 unit and it's a value of y. So at that point, x is 0 and y is 1. At this point, x is 1 and y is 0, right? From here to here is negative 1. Therefore, x is negative 1 here and y is 0. If you come here, remember this is negative 1 of y. So x will be 0 at that point and y will be negative 1. Okay, so let's start with this 4 because they are very special compared to the rest. So if you are looking for cosine of 0, it will be what? 1. If you are looking for sine of 0, it will be 0, because sine depends on the coordinate of y-axis and cosine depends on x coordinate. So if you move to 30 degrees, so remember this is 30 degrees, or what? Pi divided by 6. It is either 30 degrees or pi divided by 6. So the coordinate at that point is what? Root 3 divided by 2 and 1 over 2. This is the coordinate at that point. So cosine of 30 degrees will be this, and sine of 30 degrees will be this. Then the next one after 30 is 45. So this is either 45 degrees or pi divided by 4. The coordinate at that point will be the same, because this line is halfway between 0 to 90 degrees. So we have root 2 divided by 2 and root 2 divided by 2, which means that cosine and sine of 45 degrees will be the same, root 2 over 2. And 60 degrees, which is right here, has a coordinate of what? 1 divided by 2 and root 3 divided by 2, which means that if you are looking for this is 60 degrees, right? Or a radian, it can be written as pi divided by 3. So cosine of 60 degrees is 1 over 2. Sine of 60 degrees is the corresponding value of y at that point, which is root 3 divided by 2. And for 90 degrees, remember this is 90 degrees, or pi divided by 2. For cosine of 90, it will be 0, and sine of 90 will be 1. So these are the only things we need. We can use this to find the rest. Okay, I think, yeah, we have this and this already. So the only ones we need to find, this 3, this 3, and this 3. Let's continue. Which angle is this one? This angle is 120 degrees. So it is either 120 degrees or in radian as what? 2 pi over 3. 2 pi over 3. So what will be the corresponding value of x and y at that point? So remember that this is what? Positive, this is negative. And the point here will depend on this point and this point. But for the above point, which is on y, will be the same with this one. You see that? So this is for y, which is root 3 divided by 2. But for this one, which is positive 1 over 2, will be the corresponding value here, which is negative 1 over 2. So it will be negative 1 over 2, comma, positive root 3 divided by 2. So let me write it like this. Negative 1 over 2, comma, root 3 divided by 2. So this is the coordinate at that point. If you are looking for cosine of 120 degrees, it will be negative 1 over 2 or negative 0.5. And if you're looking for sine of 120 degrees, it will be root 3 divided by 2. So I told you that once you master this, you can find the rest. And for this one, the next one will be 135 degrees. This 135 degrees must correspond to this one. So they will have the same values. The first one, which is x, because this x is negative, it will be negative. But for y, since they all depends on the y at 90 degrees, they will remain what? Root 2 divided by 2. So this is a reference angle to 45 degrees. So the first one will be negative root 2 divided by 2, and the next other one will be root 2 positive divided by 2. Simple. Then this one and this one will correspond. Which angle is that? It is 150. Remember, this is 135. So for 150, we have the coordinate which correspond to this one, right? So we have negative root 3 divided by 2, but this will remain positive because it is for y, comma, 1 over 2. Then this is already like that. Then coming here, you see that this depends on negative axis. This also depends on negative y axis. So every point here will be negative. Which angle is this? This is 210 degrees or 7 pi divided by 6. So the coordinate will correspond to this one. You see that? So for x, they will be the same. For y, it will be negative version of that because this is negative y axis. So we have negative root 3 divided by 2, comma, negative 1 over 2. So if you're asked to find cosine of 210 degrees, it will be this, and sine of 210 degrees, it will be this as well. Let me write the angles there. This is 210 degrees or 7 pi divided by 6. Remember that this is 180 or pi. This is 150 degrees or what? 5 pi divided by 6. And this one here, I don't want to mix things like that. It will be 135 degrees or 3 pi over 4. All right, let's continue. Then after 210, we have 225. So this angle here will be 225 degrees or in radian as 5 pi divided by what? 4. So what is the coordinate at that point? It must correspond to this one. Look at it here. So we have negative root 2 over 2, positive root 2 over 2, but in the third quadrant, all of them are negative. I'm going to tell you something important. So this is negative root 2 over 2. If you observe, this is a reference of 45 degrees in first quadrant. Negative root 2 over 2 as well. Then what about this one, which is 240? 240. O in radian as 4 pi over 3. Its coordinate will correspond to this one, which is negative 1 over 2. And the other one is positive, but in the third quadrant, all of them will be negative. So we have negative 1 over 2, comma, negative root 3 over 2. Negative root 3 over 2. So if you are looking for cosine of 240 degrees, it will be negative 1 over 2 or 4 pi over 3. Then this is 270, right? 270 and 3 pi over 2. Cosine of 270 will be 0 and the sine of 270 will be negative 1. Or you can use radians as 3 pi over 2. We'll move to the next one, which is 300. So this is either 300 degrees or 5 pi over 3. 5 pi over 3. So it must correspond to which one? This. You can always use the first quadrant as reference. So it will be negative. Oh no, for x, it will be this, right? Because x is positive at that point. So it will be positive as well, 1 over 2. But for y, it must be negative because y-axis at that point is negative. So it will be negative root 3 divided by 2. Okay, it will block the other one. So let me do it like this. 1 over 2, comma, negative root 3 over 2. Then the next angle will be what? 315 degrees. And 315 degrees has what? Coordinate that will correspond to this. One is positive, the other will be negative. So it will be root 2 divided by 2, comma, negative root 2 over 2, which is a reference of 45 degrees. So second to the last one, which is 330 degrees, will correspond to this one. X is positive, but y is negative. So for x, we have root 3 divided by 2. For y, we have negative 1 over 2. So this is 330 degrees or 11 pi divided by 6. So I think we have written all of them. So the moment you have this, you are good to go. So the next thing I would like to tell you about the unit cycle is the sign of these ratios. You can clearly see that. So let me clean all of this. The first quadrant, this is the first quadrant. All ratios are positive here. All of them. This is second quadrant. Only sine and its reciprocal. Sine. What is reciprocal of sine? Cosecant. Cosec. Only sine and its reciprocal are positive here. Here, all of them are positive. Sine, cosine, tangent, they are reciprocal, all of them. Why? Because this leg and this leg are all positive. But if you come here, only this leg is positive. This will be negative. I remember that y depends on sine. So sine and its reciprocal will be positive here. So if you come here, you can see that this and this are negative. So sine and cosine will be negative. But remember that tangent is a ratio of sine and cosine. And whenever you divide negative by negative, you get positive. Therefore, tangent here, this is what? Third quadrant. Third quadrant. We have tangent and its reciprocal, which is cotangent. Cotangent and tangent are positive here. And lastly, you can see that only this leg is positive in the fourth quadrant, which depends on x, right? Which is cosine. So only cosine and secant are positive here. So how can you remember this? All science students take calculus. All science students take calculus. All all the ratios, science students. S here should remind you about sine. Tech. T here should remind you about tangent. Take calculus. C here should remind you about cosine. Why do we need this? Because we know that we can use the points in the first quadrant to determine all other points in other three quadrants. So you only have a difference of sign. So if you're in the first quadrant, you should know that they have all positive signs. In the second quadrant, only sine is positive and it's reciprocal. In the third quadrant, only tangent is positive and it's reciprocal. While in the fourth quadrant, only cosine and its reciprocal are positive. So I think this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.